Oh, hello there. So today we'll be talking about RAM, so let's get into it.
What is RAM? RAM stands for Random Access Memory, and it is a physical hardware that temporarily stores data. It is installed in a memory module slot on the motherboard.
This is an example of a RAM module. The whole module is based on this green board, which is known as the printed circuit board. The printed circuit board is made up of many layers, each containing traces and circuitry. The more layers a printed circuit board has, the more reliable the module gets. These golden stripes are known as pins. These pins connect the memory module to the system board to allow for transfer of information between the two. These black squares are called memory cells, and they are what actually stores the data in the RAM module.
Dynamic RAM, which is also known as DRAM, contains capacitors and transistors. Bits of information are stored in the capacitors and transistors. The capacitors has to be constantly refreshed with electricity, otherwise the information they are holding will be gone. It runs asynchronous with the system clock and is cheaper than SRAM. It is typically used in the computer's main memory.
Synchronous dynamic RAM, known as SDRAM. It is used in today's RAM, dual inline memory module, or known as DIMMs for short. The difference between DRAM and SDRAM is that DRAM operates asynchronously with the system clock, while SDRAM operates synchronously with the system clock. All signals are tied to the system clock for better controlled timing.
In synchronous transmission, data flows in a full duplex mode in the form of blocks or frames. Synchronization between the sender and receiver is necessary so that the sender knows where the new byte starts. While in asynchronous transmission, data flows in a half duplex mode, meaning one byte or a character at a time. It transmits the data in a continuous stream of bytes. In general, the size of a character sent is 8 bits, to which a parity bit is added. It does not require a clock for synchronization. Rather, it uses the parity bits to tell the receiver how to interpret the data.
DDR SDRAM operates like SDRAM, only twice as fast. DDR SDRAM is capable of processing 2 read and write instructions per clock cycle, hence the double. Although similar in function, DDR SDRAM has physical differences versus SDRAM, like the number of pins, for example. DDR SDRAM also works at a lower standard voltage, preventing backwards compatibility with SDRAM. Each version of DDR SDRAM boasts lesser power consumption and faster speeds, but each version is not forward and backwards compatible.
Graphics Double Data Rate SDRAM, also known as GDDR, is a type of DDR that is mainly used for graphical processing. It is used with the GPU for data-intensive programs such as games and animation. It has its own progression types from GDDR1 to GDDR6, which is the current latest version. Each generation improves performances and reduces energy consumption, just like DDR. However, GDDR favors bandwidth over latency. GDDR can receive and send data on the same clock cycle, while DDR cannot.
ECC memory stands for Error Correcting Code Memory. ECC is a method of detecting and correcting memory errors. These errors occur when data is read or written differently, such as variations in voltage on the motherboard, causing bits in memory to flip. ECC memory uses an even parity to detect these errors. The way ECC does this is by generating an extra bit called the parity bit. It counts the number of ones in the binary code and sets it to an even number. This is then encrypted and stored into the main memory. While checking of the code is required, it checks the sum of all the ones in the code. If the sum is even, this means that there is no error. However, in the case of an error, the sum is not even, and the ECC RAM retrieves the correct code from the main memory.
Thank you for watching.